Okay, this is not in the note spiral, but I know that my students tend to struggle with distinction between cluster and stratification. So I work hard to do that, to help with that. And so here's my attempt. We're going to look at cluster again. So let's pretend like we have a population of A, B, C, and D. So this is our population. And let's just say we have millions of A's, B's, C's, and D's. So basically, my population is comprised only of A, B, C's, and D's. And so I can break the population down into little microcosms. And here they are. They all have A, B, C, and D. They may be slightly different in the way they look, but I have 5 little microcosms that mirror the population. They have all the elements of the population. So I might randomly select 2 numbers. So let's just say I randomly selected number 1 and number 6. So I randomly selected number 1 and number 6. So those are the clusters I randomly selected. And then I would survey A, B, C, and D. And then over here, I'd survey A, B, C, and D. So I basically, once I make the random selection, because it's a cluster, I randomly select the cluster that looks like the population. I survey everything in it. And then I say, you know what? A, B, C, and D, this is what they came up with. So this is what our population likes, or the characteristic our population has. I contrast that with a stratified. So we're still working with the population made up of A, B, C, and D. All right? But I've broken them down by a similar characteristics. The characteristics, the strata is the strata for A's, this is the strata for B's, strata for C's, strata for D's. Obviously, this strata does not look like the population because it doesn't have any B, C's, and D's. This one does not look like the population. But if I combine all 4 strata together, they do look like the population. So I have my strata, I divided it by something similar characteristic, which obviously is the letter here. Then I randomly selected. So I randomly selected an A, and it happened to be the 3rd A. I randomly selected a B over here, and I randomly selected a C, and I randomly selected a D, and I surveyed those. By surveying those, guess what? My stratified sample looks like the population now. All right? So the advantage to a stratified sample is I make sure I get every element of the population. Well, if I have every element in my microcosm, the cluster works just as well for that. So I tend to find that people still get confused as to which one I'm running, a stratification or a cluster. So here's my best attempt at explaining this. Once again, my population is still A, B, C, and D. So this is my population. And we immediately go, oh, okay, this is stratified. Because we go, you know what? It is broken down by single characteristic. So there's my first strata. It happens to be my strata for the A's. Here's my strata for the B's. Strata for the C's. And the strata for the D's. Obviously, I would randomly select within this the A's, randomly select within the B's, randomly select within the C's, randomly selected with the D's, just as I did right here. And that way I end up getting a stratified group of A, B, C, and D. However, this same design also represents a cluster. I just need to circle it this way because there is one cluster. Looks just like the population. Okay, so the big differences are, and please listen carefully. Cluster samples, each cluster looks like the population. Each cluster is a microcosm of the population. We randomly select one or more clusters and survey everything, every element in the cluster. That way we make if I choose this one, then I'm going to survey A, B, C, and D. With the strata, I'm going to go to each one of the stratas and randomly select within. Okay? And once again, cluster. Each cluster is a microcosm of the population. We randomly select a cluster, and then they survey everything in that cluster. Stratified, we've broken it down on a common characteristic, and we go to each one of the strata. So we choose each strata and randomly select some from within the strata. That's the difference.